Okay, yesterday I taught you about polynomials and how they end. You know what I mean? Like they were ending going down, or on this side it was going up. That's called end value. And I also taught you some terminology like what's the lead coefficient? Does that ring a bell? And what degree is this polynomial? So let's just do a couple really quick ones. If I did have a graph that went like this, then was its degree odd or even? Its degree was odd because these are going different directions. Did it have a lead term that was negative or positive? Negative, because the right side is down. There must have been a lead term that was negative. And then what's the y-intercept? Well, how about this? At least you can tell, was the y-intercept of like a small positive number? Yeah, because of this, we can tell the y-intercept of our equation must have been that. All right. You also, if I gave you an equation, should be able to answer some things like what's its lead term? What's its lead coefficient? Coefficient's the number in the front. What is the end value on the left, end value on the right? So I've got 5 questions for you about an equation. And you're going to see if you can, shouldn't just be like, oh, I got 4 out of 5, that's pretty good. You need to be able to get 5 out of 5 because I'm giving you a partner. And together you need to be able to pull off 5 out of 5 on this. It's a review from yesterday. So I'm going to pair you right now and then put the problem on the. So there's your equation. Now, here's the questions you could be asked about this. This is one of those units with a lot of little things to know. They're not that hard, but there's a lot to know. Like, for instance, you'd have to be able to tell me what is the lead term. Number 2, you don't have to write out the questions, but you do need to write out the answers. Okay. Number 2, and you can confer with your partner, what is the lead coefficient? Number 3, how many terms does it have? Number 4, what's its degree? Number 5, what's its right end look like? All you have to say is up or down. Number 6, what's its left end? I always start with the right end, and then I just decide, is my left end the same or different than that? So start with the right end. And last, number 7, lucky 7, is sketch it. What generally does it look like? All right, I'm going to pause for a second. I'm going to give this one a try and see if you can get, actually I added a couple little things in here to make it 7 points. Lucky number. Okay, most kids seem to be done. The first thing is the lead term. I tried to trick you. I don't know if I caught anybody. That's the lead term. Why? Because it's got the biggest power. So if you were basing everything on 4x to the third, you just got them all wrong. Just be careful with that. I'm not going to ask who did that, but I'm sure there's somebody in here who probably did. All right, questions so far? That's the lead term. So it's negative 2x to the 5th. So it tells us all the important stuff. Like this negative in front, it tells us that it's what? What does that negative tell me? Down on the right. Good. So at the end of your sketch, it better have been going down. Next, it's got a 5 for its power. That tells me a couple of my answers here. Okay, we already know it's down on the right from that. What does that 5 tell me? The degree. And what else? Since it's odd, it's telling me, hey, the other side's got to be different. It doesn't say whether it's up or down. You have to judge that. It just says, odd, that's different. It should be different than this, and therefore up. Okay, so it must be up on this end. And then the lead coefficient, that's the number part of the lead term. Negative 2. Yes, you include the negative. And last but not least, how many terms are there? Oh, 1, a 2, a 3. Does that 2 count as a term? Yes, it does. There's 3 terms. That is called, I scribbled one out. Sorry, that does, yeah, that counts 2, sorry. It's a 4-part polynomial. Now, usually call them monomial is 1, binomial is 2, Trinomial is 3, and then after that, they stop counting. They just call them poly. You get what I'm saying? Monomial is 1 term. You can have one with just 1 term. Bi is 2, tri is 3, and this is after 4. You could go with quadnomial, but it's not actually said. Usually after 3, you just start saying polynomial. Kind of like in the shapes. Do you know that they give names up to 12? Dodecagon is the 12-sided shape, but then after that, they're called 13gon, 14gon, 15gon, 16gon. See what I'm saying? Just keep it simple. After you get a certain number, you just call them something simple. So this is a polynomial. I wouldn't say a trinomial, because that would be if this actually didn't exist, then it would have been a trinomial. All right, anyway, now the sketch. The only thing I need to include is that it goes through 2. That blue part, that's the part you're going to learn today. How do you figure out what it's doing in between? In the between times. Okay? So, how many of you got 6 out of 7 or better? I'll afford for one little mistake. Okay, good. That means pretty much everybody's on top of what we learned in the last day. All right, so this is day 2 of polynomials. So now what do we learn? The middle part. What's happening in between? Get to this slide right here. Actually, I should go back here. This is where it tells me, the very first slide, what I'm teaching you. Increasing and decreasing. Do you get if this is a stock market, that a stock market generally is up? I don't know if you know that, but the stock market's up right now. It's been up for the last like 8 years. It's gone up, 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 up. Okay, so has it gone up every single day? No. There's some times where it goes down. But then on average, the stock market is all the stocks, which is basically part ownership of all the companies that are public companies in the United States. They've gone up in value. So that can be like for a lot of different reasons. I'm not going to talk much about the stock market here, but do you get from here to here? The stock market was going down, also known as decreasing. Okay. If you read it from this way to this way, it would actually look like it was going up. But that doesn't make any sense because we only read from left to right. That's important to remember. Okay, so this, even though you could argue if you go this way, it's going up, but if you go this way, it's going down, you never go that way. You only go from left to right. So that little blue zone there, that's increasing. So we're going to talk more about increasing and decreasing. And then maxes and mins. Do you get this little spot right here was kind of a high spot for the market right there? It was like the day before that, it wasn't that high. It reached a high spot and then it went down. That's called a maximum, but it is a special kind of maximum. It's not the highest spot of all. That is called either you can call it a local maximum or you can call it a relative maximum. Relative to the people nearby, or the prices of stocks on the day before and after, relatively it was a high spot. That's a relatively high spot. That's a relatively high spot. That's the highest spot it ever was. That's what we're near on the stock market right now, is the highest spot it ever has been. Okay, that's not just a relative max. That's called an absolute max, the highest it's ever been. Okay, there are people. There's a person who has been the farthest out in our solar system. Someday we'll probably send a person to Mars. Then they will be the absolute max. They've been the furthest from Earth that anybody has ever been. Right now, there is an astronaut, one person, who has been the farthest of anybody. Okay, there's other people who have been relatively far up. If you've ever been on a plane and gone up in a normal plane, you've gone up, probably up about 5 miles above the Earth. Okay, that puts you in a small percentage. There's actually not. There's a lot of people in the world who've never been on a plane. Their highest height they've been in is 0. They've always been on the Earth. You know what I mean? You've been up in a plane, you've been 5 miles above the Earth, you're in a select club if you've flown on a flight like that. Okay, that makes you have a relative maximum compared to other people. All right, how about also in your groups? This might be a little uncomfortable, but it's a reality. Do you get between the two people that are sitting next to each other, one of them might be better than the other at math? If I looked in the grade book, you probably wouldn't have the exact same percentage. You know what I mean? And sometimes it's like maybe not even ability, it's how hard they try. Because somebody might be really smart, but they just don't really care that much about math, so their grade isn't that good. But if I just look at grades, one of the two of you has probably got a higher grade. You are the relative maximum. If you're the highest grade in the whole class. That makes you the absolute maximum. You know what I'm saying? So let's say between these two people, let's say one of them has a higher grade than the other. I don't care. Pick a random one. We're doing a brighter color. I'll pick you. Okay? So then, let's say he's got the higher score of these two, and he's also got the highest score in the class. Let me ask you this. Is he the relative maximum between these two? Yeah. Is he the absolute maximum if he's got the highest score in the class? Yes, you can be both. That frustrates kids. Usually they're like, no, no, no. You said he was this. You can be both. You can be both relatively in your small group, the best student in the small group, and you could be the best in the whole class. Let's do it with strength. Do you get that there are some kids who like lift weights and they're pretty strong? Like you go in the weight room, they're like, holy crap, he's like lifting a car. All right. So there was a kid at our my kid's school. It was like that. He actually bench pressed people, and so anyway, he was a really big guy, and so he was the strongest kid in the school. Could it be possible he was also at some moment the strongest kid, like under 16, in the whole world? Is that possible? Yeah. So he could be both the local maximum, strongest kid at the high school. Everybody knew it, but maybe even the absolute maximum. So you can be both. That's a key question. Is this locally, relatively a maximum? Yes. Is this the absolute maximum? No. Is this a relative max? Yes. Is it an absolute max? Yes. It can be both things. Okay. Yes.
You know that people are making an airplane.
Go ahead.
That flies just above the Earth's atmosphere.
Okay.
And it skips on the atmosphere.
Ooh, that's kind of cool.
They go above the atmosphere and they cut off.
Are they using solar power?
I'm not sure.
Okay.
Then
it bounces, skips across the atmosphere. That is cool.
It goes like 5 times faster with less fuel.
Well, it makes sense because you're outside the atmosphere. That means there's no wind resistance up there at all, or even air resistance, right? So theoretically, in space, you're in a vacuum, and that means you can travel like super fast without any resistance. It's like if you were running on Earth, you run, and then imagine if there was no resistance. If you ran and you got going a certain speed, you would just keep going that speed. You know what I mean? Without any effort. Kind of a cool concept. All right, let's look at this. That's the last thing I got to teach you is how to write an equation for it. So, like, I can tell you how to write an equation for this. It looks crazy, but I don't even have to know all of the points on it, but I can tell you how to write an equation for that. That's pretty powerful to be able to look at a graph and say, oh, I can write the equation for that. Now, I know you could write a simple one. Like, you might be able to tell me the equation for this. Like, if I tell you its vertex is at 3, 0, you could write me an equation for that. You can do simple ones, but I'm going to show you how to do complicated ones. It's kind of like that. Do you remember how to write this equation? If its vertex forms, this ring a bell, x minus 3 squared, and then that's a parabola that's been moved to the right 3 spots that look about right. Is it possible there's a stretch factor I can't see? Yeah, and if there's a stretch factor of 2, I could throw a 2 in front. That's how you write an equation. You already know that. But I'm going to show you how to write equations for things that are like this, for instance. I can say, oh, that's not that hard. Tell me that point and that point. I can tell you what the equation is for that. And I'll show you that. All right, so that's the goal for today, is increasing and decreasing, maxes and mins, which I pretty much already covered. And then last, how do you write an equation for stuff? All right, so find for me this page right here, increasing and decreasing intervals. All right, so do you get that in this zone right here, if this was like the stock market, that was a bad week for stocks or a bad day for stocks. It was decreasing in there. How do I say it was decreasing in there? Well, of these two, I'm going to write an interval. An interval looks like this, from here to here, something to something. From something to something. Now, this is counterintuitive. Most kids will say that it's how high it was compared to how low it was, and therefore they want to pick the y's, but that's not right. You want to pick the x's. What you want to try to say to people is from here to here, in that blue zone there, it was decreasing. So how do I do that? With the x's. So when you're doing your intervals, just always remember to pick the x's. So it's from there to there. Negative 3.6, there's negative 3.6 right there. From negative 3.6 to negative 0.9, that's about negative 1. So basically between here and here, it was decreasing. If you can't understand all of that, for now, just hold on to this. They're the x numbers. Negative 3.6 to negative 0.9. Okay, that's where it was decreasing. How about this? I'm going to draw on this and say, in this black zone here, would you agree the stock market or wherever this was increasing in there? Tell me how to write that interval. What to what? Now you might be like, but one of the points isn't labeled, but you can figure it out. I'm going to pause for a second. You try to figure out that black increasing interval there. He says negative 0.9, and I know he's right because that's the x of this. Okay? So you said 1. Now, I'm going to check this. This point, would you agree, is 1 comma 0, and therefore you chose the x value of it, and therefore you're right. Raise your hand if you had that right. Okay, good. Now, it gets harder when they go forever, because then one of your things got to be infinity, right? In this next little zone, this red line keeps going, and it doesn't have an arrow on the end, but I'm going to say it does. So let's make this blue section. How do you say in that interval it's going to keep going down forever? Well, that's decreasing, right? So from what to what? How do you say that it's decreasing at that end of the function? All right, well, first of all, I've pounded on this whole x value thing, right? So it's obviously the x value of this, so it's got to be 1 to, and then here's where people get confused. They're like, is it infinity or negative infinity? Here's the arguments. It's going down, so therefore it's negative infinity. Or, we're going to the right, and therefore, if we're going to the right, it's positive infinity. What should win? Which argument should win? This is where positive infinity is. This is where negative infinity is. And I know you're like, but it's right by the negative infinity. But which are we doing? The x stuff? Yeah, it's the x stuff. So it's going to positive infinity because that's what x is. If you're saying it's negative infinity, that's what y is doing. Y is going towards negative infinity. What we care about in these is the x's. So that's positive infinity there. All right, last one. Here's a picture. I'm making this one up. It's a very typical one. It's got a high spot at, let's say, 1 comma 7. And it's going down forever that way, up forever that way. And it hits at, let's say that's 6 comma 0. I'd like you to tell me how to say this interval, the green one. And then I want you to tell me how to say this interval, the black one. How do you say, math-wise, this? What's it doing from where to where? And how do you say this? It's about increasing and decreasing. So I know I'm being a little vague, but I'm trying to see, do you understand what I was trying to teach you? It's about identifying intervals where the function, the polynomial, is increasing or decreasing. In the green zone, sir, what do you say? 1 comma 6, and you just told me that it was doing what? Decreasing from 1 to 6. That is a correct answer. Good. All right, now some people get obsessed with the parentheses and brackets here. Don't. It's fine to use brackets or parentheses. I personally just use parentheses because they're just more common. But the argument would be, is it still decreasing at that point? Well, it's just kind of one of those dumb arguments. It kind of is, but it kind of isn't. And so I'm fine with brackets or parentheses around your intervals. All right, how about the black zone, dice of destiny? Who should I call? Row 3, person 4. Up. That's you. 6 to infinity is correct. Remember, those are x numbers. This is the x, and then infinity for x is over here, and so it's positive infinity. You could have even messed this one up and thought it was up here and still got it right, because either way it's infinity. All right, but it's about the x's, so x to x. All right, that's increasing and decreasing intervals. Now those maxes and mins, just talk about those for a minute. Get to this. This is the wordy description. If you like that, my wife is actually the type who wants to read it. She doesn't want me to explain it. She wants to read it. If you're the type who wants to read it, there it is in words. But you can come back to it. I'm going to keep forging ahead because I think you already get this. Which of these points is, well, there's four kinds. The relative max, the relative min, the absolute max, and the absolute min. And I need to tell you something. There's supposed to be, see on Desmos, which is what we often use to make our little graphs, they don't put arrows on the end automatically. So you have to ask us if they're there. I'll always tell you if it's a test, whether there's supposed to be arrows or not. You can kind of assume that there's supposed to be arrows. The way you could know it there isn't supposed to be an arrow is if they specifically have put a dot on there, then that means it stops right there. Otherwise, you can kind of assume if it's just an empty tag end of a line, it's got an arrow on it. All right. So, do you see a spot that looks like a high spot? And that's a relative max. Just period. If it's a high spot, it's a relative max. Is it for sure the absolute max? No, you got to look a little closer to see if it's the highest of them all. If you see a low spot, that's a relative min, for sure. There can be lots of relative mins, lots of low spots. But there's only one lowest of them all. And sometimes there is no absolute min because it never stops dropping. All right, using those directions, try to answer these four. Sometimes there's two answers for one thing. Sometimes one point is two different things. A point can be this and that. All right, so it's complicated only because there's a lot of possibilities that you could write here, but only some of them are right. I want to pause while you give this one a shot. So here we go. The relative max. Is this relatively a high spot? Yeah. So that's one of the relative maxes, negative 3.6, comma 0.7. If it's the absolute max, it's also here. And it is. It's both. Now, are there other absolute maxes? Yes, there are. Right over here, this lonely point that we never called out with a parenthesis, but you can know what it is because you just look and you can see it's 1, 0. That's not the absolute max. It's not the highest, but it's a max. So we should put it on this list at 1, 0. How many of you remembered that spot? It's easy to forget because it doesn't have parentheses. All right. Next, this spot here. Is it important? Yeah, it's important. Is it the lowest of them all? No. But it's a relative min. And is there an absolute min? No, there is not. There is no lowest spot. You would say none. And I know somebody's going to ask me, could I say negative infinity? But that's not a point. It's a concept. Is that what you were going to say? Okay. All right. Let's move on. You can write equations for these. You already know how to do that. Okay? None of them even have stretches, so it's pretty simple. Would you just write me an equation for this one? This one, you remember how it touches here? Or you could use the vertex of it, but I personally use the roots. And this one here, this one personally, I would use the vertex formula for it because it's a little less confusing. All right, try to write the equations for those. You should already know that, and I'm going to remind you in a second if you've forgotten. But we're going to move on to the complicated ones in a minute. Okay. Did you have x minus, because it's the opposite of what you would think, 1? Raise your hand if you had an x minus 1 in there. Good. And if you had that's a negative 3, so I say x plus 3. Does that ring a bell? All right. If you did this with vertex form, that's not going to help as much today. This one's x minus 1 because it hits at positive 1. And there's a double root there. So I'm going to say squared. Or you could have said that's vertex form, except you could put a plus 0 at the end if you want to. Either way, that's the answer. All right, so there's your 2 that you should already know how to do. Yes? Ooh, you got me. There, it's going down on the right, and therefore there's a negative right there. Very good. Thank you for noticing that, because that happens a lot. I miss it a lot too. I'm like just normal human on that one. You just have to either notice it or you don't. If it's going down on the right, you need a negative thrown in front. Okay. Now, was there a stretch factor? No, because I go over and down one, just one and one. It always should go to that spot, and it does touch that spot, so there's no stretch. This one, over one, up one, it's at that spot, so there's no stretch. Okay, moving on. How do you get the equation for that one? This is tougher, but I think if I show you, we're getting low on time, so I better jump to it. I think you'll get that there's 3 spots it touches, and so each of them need a parenthesis. Does that much make sense to you? The other one had 2 spots it touched, so we had 2 parentheses. Now we got 3. Next thing, before I forget, what was that thing somebody burned me on last time, and I don't want to happen again? It's negative in front. Why? It's going down on the right side. Awesome. Negative right there then. And each of those parentheses needs to be for a spot. That's at 1, so I'm going to go put x not plus 1, minus 1. And this spot right here, that's at negative 1, so I say x plus 1. You always do the opposite of what you'd think. That's at the spot negative 2, so I go x plus 2. Because negative 2 is a root for it, so it all makes sense. That's supposed to make it equal 0, and negative 2 goes into that factor. Okay, so anyway, if that was it, it would be super simple. This wouldn't be honors pre-calc. Sorry, honors higher algebra. This isn't honors pre-calc. Anyway, this wouldn't be the honors version of the class if it was that simple. All right, so there's just one more thing. Which of these 3 looks like a parabola and therefore should be squared? The left one, the middle one, or the right one? Middle one. Which one is the middle one? It's this guy. And it looks kind of like a parabola. So you put squared there. I'm almost done, but I'm not quite done. Which of these kind of looks like this graph, which you should know from the past? Do you remember that guy? X to the 3rd? Does that ring a bell? Okay. Which of them kind of looks like that, except flipped? The one on the right. So it's to the 3rd. And there's your answer. This one doesn't have anything on it. Could I put a 1 just so it doesn't feel naked? Sure, you could put a 1 there. Don't have to. All right, then, final answer. That's your equation. If there was a stretch factor, we wouldn't know it because we're not ready for that yet. There'll be too much for one day. Okay? Yes? Is it usually written in that order? Yes, it's nice if it's written in that order because this one goes with the first one, this one goes with the middle one, this one goes with the last one, but it's not required that they be in that order. Okay. Now, there's 2 more big words that I need to remind you about. Degree. If I was to pull out the lead coefficient, it would be negative x to the 1, 2, 3, 5, negative x to the 6th. So what degree is this guy? Degree 6. All right. Now, they're going to ask you it this way. They're going to say, what's the lowest possible degree of it? 6. Because there might be roots that we can't see. They're called imaginary roots. So they're going to say, what's the lowest possible degree? And the answer would be 6. Yes. Actually, can you wait 1 minute? Got to finish 1 point, and then I will gladly talk. Okay. So this equation here has degree 6 because its lead coefficient would have been a 6. That's this, this, and this, and then that negative included. Okay, and then the only other thing is they are going to ask about a word called multiplicity, and that just is each of these has a multiplicity. It's kind of like degree. The multiplicity here is 3. The multiplicity here is 2. That's a multiplicity of 1. All right, and if you understood what I just told you, you should be able to make the equation for this guy based on these 2 roots. Write the equation. Gets 2 parentheses. All right, see if you can do that and check with the kid next to you. Did you say that 3 was kind of important? X minus 3. Raise your hand if you had that one right. Then, did you say that 0 was kind of important? Could I put x minus 0? Yeah. Could you put x plus 0? Yeah, but what's even faster?
X
just x, because x minus 0 is the same thing as x, isn't it? All right. Then, last but not least, one of these is acting weird. It's bouncing. So this one should have been squared. Because this one isn't bouncing. This one's just cutting right through. Bouncing. Look at that as like the path of a ball. Do you get how that, look at the red one now. See how that's kind of like a ball bouncing off of the x-axis? That one's going to be squared. This one just drops right through it. That one is a normal one. It's not bouncing. It's just to the power of 1. And this one's also just cutting through with the power of 1. All right. One last thing on this equation that is not right, and I'm glad somebody has caught it. I'm guessing you have figured out something. There should be a negative in front. How many of you forgot to check that the end was going down and therefore forgot the negative? How many? Be honest. I was one of them. All right. See, it's so easy to forget because all you do is throw a negative on it, but you forget that negative, boom, whole problem's wrong. Seriously, like not even partial credit. So you got to go back and check yourself when there's a test and there's only 4 questions that are really important, the R3s. If one of them's flipped and you forget, boom, you just lost that question. Yes? Good question. We are not going to worry about stretch factors today. You don't have to put any today. I know there might be a stretch factor. Actually, in this problem, I already checked, there actually is not a stretch factor, and there was how I can prove it. If you put the numbers 1 and -4 into the equation, I put a 1 here and a -4 here, it works without a stretch factor. So there is no stretch. That's how you would check. But we're not going to go there today. Don't worry about that if you didn't understand what I just said. If you write out this one, there should be 3 parentheses. Write out what you think the equation is for that one. It hits at 1, x minus 1. It hits at -2, which is that spot, x plus 2. And it hits at -5, x plus 5. But then don't forget a couple more things. Were any of them bounces? This was bouncy. So that one gets a squared. Its multiplicity is 2. You'll get used to those terms over time. Its multiplicity is 2. The other guys, they're not bouncing, so they're just 1s. And last thing, is it going down on the right? Nope. At least I checked this time. So it's positive in front. Don't have to put a plus, but if it was going down on the right, we would definitely need to put a negative. All right, that's it. That's all you got to do. All right, now, your homework for tonight is a Schoology quiz. I want to remind you, just because you aren't seeing them in the grade book yet, they are in my Schoology grade book. I'm just going to be transferring them en masse, in a big quantity, into the Skyward grade book as clumped together one big grade. So if you're like, I keep doing these things, but I keep not getting credit, you will. And for those of you that have been skipping them, if you start now, I will say that the ones that I'm doing from now to the end of the year are going to be weighted heavier. Meaning, if you just straighten yourself out and start getting those Schoology quizzes done regularly from now on, you can still help your grade out a lot. All right, that's all I got for you for today.